Electrical energy and power. By the end of this lesson, you should be able to define electrical energy, define electrical power, solve problems involving electrical energy and power. Here are some examples of appliances that you can find at home. Can you name other appliances? What makes it possible for the toaster to toast a piece of bread? What makes it possible for us to see pictures and hear sounds on the TV? What makes it possible for an iron to make clothes smooth? What makes it possible for the bulb to light up? What makes it possible for the bulb in the torchlight to light up? Electricity enables us to light our homes and cook our food. How much electrical energy do the toaster, TV, iron and bulb use? How much power does an electrical appliance need? Why does the bulb light up? When the electric current flows through the filament in the light bulb, the filament becomes hot and glows. Can you state the change in energy when the torchlight is switched on? Electrical energy is converted into heat and light. The energy conversion in the light bulb obeys the law of conservation of energy. Can you state the law? The law of conservation of energy states that energy cannot be created nor destroyed, but can be transformed from one form to another. What is the source of electrical energy for the light bulb? The electrical energy is supplied by the dry cell. There is a potential difference across the terminals of a dry cell. How is potential difference of a cell related to energy? Potential difference between 2 points A and B in a circuit is equal to the amount of energy converted from electrical energy to other forms of energy when a unit charge passes from one point to the other. Potential difference V equals to energy converted E divided by the amount of charge flowing Q. Thus E equals to Q times V. How is electric current related to rate of charge flow? Electric current I equals to the quantity of charge flow Q passing through a point in circuit in a given time t. Substituting Q equals IT in E equals QV, energy E equals current times time times voltage. Since V equals IR, energy E can be rewritten as E equals I squared RT. Substituting I as V over R, energy E then equals V squared T over R. The units for the physical quantities together with their symbols are given in the table. What does the label 750 watts represent? Label of 240 volts means that the toaster will operate at a voltage of 240 volts. 750 watts means 750 joules of energy per second is required to toast the bread. What does the label 240 volts, 1000 watts represent? Consider an electrical circuit with a resistor. What is needed to move charges through the resistor? Energy is needed to push the charges around the circuit. In other words, work is done to move charges around the circuit. What can you say about the quantity of charge flowing when more batteries are used? Click on the button to select the number of batteries. As the number of batteries increases, the number of charges that flow around the circuit also increases. What can you say about the work done in moving the charges around the circuit? More work has to be done or more energy is needed to move more charges around the circuit. What is the meaning of electrical power? Power is the rate of performing work or the rate of energy transfer. In other words, power is how quickly the work is done or energy is transferred. Power P, either delivered or consumed, is equal to work done, W, in a given time, T. Power is the amount of energy converted in a given time. Therefore, energy equals power times time. Since E equals Q times V, thus power is equal to charge Q times potential difference V divided by time T. Therefore, power can be written as current times time times potential difference divided by time. So, power is equal to current times potential difference. Using Ohm's law, where V equals I times R, other alternative equations for power can be P equals IV. Therefore, power is equal to the square of potential difference and divided by resistance. Thus, power is equal to I squared times resistance R. What is the rate of electrical energy used by the vacuum cleaner? The vacuum cleaner uses 1,200 joules of electrical energy per second. Calculate the current used by the vacuum cleaner. Current I equals power divided by potential difference equals 1,200 watts over 240 volts equals 5 amperes. Click the Start button to start the vacuum cleaner. Calculate the energy used by the vacuum cleaner for the different duration of usage. How does the electrical energy consumed by the vacuum cleaner vary with the duration of usage? When the duration of usage increases, the electrical energy consumed also increases. How can you save electrical energy while vacuuming the same area in your house? Vacuum the same area in a shorter time. Click on the bulb. Click on the switch, the circuit. Calculate the current flows and the resistance of each bulb. What can you say about the brightness of the bulb when the power of the bulb increases? When the power of the bulb is increased, the brightness also increases. What can you say about the power of the bulb and its resistance? The higher the power of the bulb, the lower its resistance. What can you say about the thickness of the filament in the bulb and its resistance? The thicker the filament in the bulb, the lower its resistance. In other words, the bigger the diameter of the filament, the lower the resistance. Identify the type of the circuit used in household appliances. The household appliances are connected in parallel circuit. Wires that carry current to electrical appliances have a small resistance. What will happen if there is no fuse and a large current flow in the circuit? If the current is large, the wires will heat up. What will happen if the circuit is overloaded? If the circuit is overloaded, the wires will become hot enough and could start a fire. How to prevent overloading of current in a circuit? To prevent current overloading, fuses or circuit breakers should be installed in the circuit. For example, a 40 amperes fuse will break the circuit when the current passing through it exceeds 40 amperes. What are the possibilities for fuses to burn out or circuit breakers to open repeatedly? Among the possible reasons are: 1. The usage of too many electrical devices simultaneously will cause the effective resistance to be very small, thus causing a large amount of current flow in the circuit. 2. The occurrence of short circuit. This happens when two wires have crossed, so that the path of the current is shortened, thus causing the effective resistance to become small. This will then lead to an increase of current flow in the circuit. The main supply uses a 25 ampere fuse. Calculate the total current flow in a household circuit when the electrical appliances are being used. Will the main fuse blow? Click on the switches to see the answers. What can you say about the importance of the usage of fuses in a household circuit? Fuses should be installed in the home electrical circuit for user safety and prevention from fire.